All right. Ladies and gentlemen, welcome to the third broadcast lecture on Twitch. Again, as we've talked about, we're continuing to explore technologies. Today's lecture isn't quite as polished as I would have liked because you may recognize that is the Bain Center staircase. And at 12:15 today, we had a six-truck fire alarm, which would have not been too bad, except for the repeated fire alarm after they left, and then another one later. So we've had a lot of fire alarms this morning, which kind of threw off our rhythm, but that's okay. Um, I thought it'd be interesting. So as they were exiting the first time, I noticed a couple things, and I thought it's kind of cool to take a look because there's a sense that you want things to be well put together, to be well designed. There's this idea that when the city is purchasing a fire vehicle or an ambulance, you kind of hope that there's been an engineer in there who's really been putting their attention to it. And so then when I zoomed in, what I noticed, this is like the coolest pry bar ever. I'm going to look into it. So I was super impressed. This firefighter was carrying this pry bar, and I was able to have a quick chat just about what they found about it. It's pretty cool. It certainly beats whatever you get at Home Depot or Lowe's. The other thing, though, that I was surprised by was just the extent to which milk crates were being used to organize the truck. So there I am thinking, milk crates are the kind of thing that my parents had when they were decorating their first house. And a milk crate, for those of you who aren't familiar, is very much, I think, a Canadian thing, because in Canada we have a lot of bagged milk, and those milk bags don't really stack well, they don't transport well. And these crates literally are where you put 4 liter bags of milk in, and yet that's now what they're using um, to arrange and store. Now, interestingly, the blue one and the brown one are two different companies' milk crates, so they won't actually stack. Um, so it's kind of just interesting to me that here we have our fire response services, and you'd kind of think that the fire truck manufacturer would design really solid, really amazing bins for them to use to organize, but they don't. And I think this is a really good example of use as intended versus use as designed. They were looking, the firefighters, for a very strong, very compact container. And the milk crate was not designed for this or intended for this, but it's going to be used for it. Okay, so that was one thing. I will point out the delay in putting lecture together was not because I was trying to choose whether or not to purchase a new iPad Pro and Magic Keyboard. I raise this, A, because as people want to say, I'm a big Apple fan, but more importantly, there's a real discussion that we've been having about reference designs. And I've had an email, and to that student, I apologize. I will get back to you shortly. Where does inspiration come from? Where does creativity come from? We're all super stressed. When you're stressed, it's kind of hard to just relax and be loose and try to channel your divergence. And reference designs is one of the things we've talked about a lot. And I don't know about you, but the moment I saw this on screen, my immediate reaction was, feels like a Manola Blahnik. It's like we got stuff that's in midair that's just kind of hanging there, but it's still able to bear load. It's still able to do what it's done. So we're going to I'll try to riff back on this idea of reference designs. I definitely will when we get to Triz. But this idea of, you're like, that's kind of cool for a shoe. Would it work for an iPad stand? Who knows? I don't know. Cantilever high heels, you got it. Um, but I have a different question for you, and this is what we're hoping starts to happen as you go through your education. Is you should be looking at that going, or asking yourself, if I wanted to know the mass of the keyboard. So right now you can go online and you can get the mass and the specs of the new iPad Pro. You can't get the mass distribution, but you can get the overall mass. Could you, as engineering science students in your fourth, fifth, sixth and a bit month of learning, work out the mass of the keyboard and the stiffness of the hinge just based on this picture? And you know, one of the things that's come up is, for beta, for as we move Praxis forward, how much prototyping do I have to do? And if you were to show us for example, let's say you were doing a stand and you were to show us, this is our inspiration, our reference design is this Manola Blahnik. And based on Civ 102, we've done some calculations and we can tell you that the stand is going to weigh or have a mass of about this much. We're going to assume uniformity, and the hinge is going to be about this stiff. That would be pretty cool. That would totally be dimensions for geometry. A quick point in Mattermost. You can get the specs, the dimensions off of Apple's website for the iPad Pro. But really what I want to say is that if, as we are moving forward as engineers, you start to think and say, okay, here's my inspiration, here's where I'm coming from, here's a sketch. Now this is an actual rendering, but here's a sketch. And then you add in plus Civ 102 estimated calculations. And then we'll say for even more, I should be looking up at you as I write. For even more, the assumptions that you've made, such as we're going to assume uniform mass distribution, which is wrong, but is it a big deal? So if you say, okay, this is kind of our prototype, this is kind of our concept, we're going to be saying, this is kind of awesome. Like, we've got this, and you've started to use your theoretical knowledge and the reference designs available to you in order to come up with some ideas. So again, we'll capture this for posterity. That didn't capture properly because I'm not capable of hitting two buttons simultaneously. Captured. Okay, now let's move on. We're going to do a little bit of an update because I think we're hoping that this course, in some senses, is serving as a hub for the NSci community. And we wanted to very quickly deal with or address a concern that's come up. And it has to do with residents. And as it says here, U of T will continue, as it says, continue to provide residence for those who cannot return home at this point, and this point keeps changing. Working on longer term ways to support students, and then there's the more information. And what we've heard from a number of you is that more information is translating into, I have to make a case to the people running my residence that I should be allowed to stay. Some of you, upon hearing this, are sort of reacting saying, look, I've heard so many negative things. Reddit is saying, Twitter is saying that they're not really being accommodating. I'm just going to sort of move out and accept it. And as much as you know, that's a temptation, if your circumstances are such that leaving residence and returning home is going to be a huge complication and a huge stress, we really suggest that you take advantage of what the university is saying. So two things. First thing, if you're in this situation where you have to make a case, it's claim and argument, and Professor Kinnear and the rest of the Praxis teaching team, we are more than happy to support you as you help you structure your thoughts and structure your argument. If you want to reach out to us, please do, because this is what Praxis is all about, is saying there are good arguments to be made, good claims to be made, and we want to help you with that. Now, it's not just us. The Dean of Engineering has designated Corey Hansen, and you can see Corey's picture right here. Corey, who I've worked with for a number of years, she used to be in the first year office. She is going to be advocating for faculty or FASC students when you're having these discussions and trying to work with your residents. So the Praxis teaching team's got your back. Corey's got your back. If you're in a situation where residence is becoming a concern or a challenge, please let us know. All right, one other thing. So the CRNCR has come out, and I've spoken with a number of students, which is why I wanted to highlight this. There are some things you want to be considering as you make your call. This is a big one. So although you will see on your transcript CRNCR, and everybody who gets the transcript will see it, there will be still final numerical numbers. And so when it comes to in-course scholarships, which are the ones that happen when you're still in the undergraduate program, or when you're going for graduating scholarships, the CRNCR will sort of disappear and we will look at the actual numbers. So just as you're deciding, be very cautious. So what I'll say is, if you if you currently hold a scholarship, some of them simply say you need your degree to be meeting your program requirements. And as it says up top, final CR can be used to satisfy program requirements. So CR and CR is fine for program. And I know that, for example, the National Scholarship and the Schulich scholarships, they are you going with your program? It's some of the other scholarships that say you need a 75% average in order to keep your scholarship. You're gonna then, the CR and CR won't hold. Just be very, very careful. Check with Perina Filippone. I don't have her contact information here. That's my error. But her name is Pierina, and her last name has F's and P's and One's, is it? She's in the registrar's office, and her responsibility is to support students with respect to scholarships. She can also, actually, this is also critically important. If you're experiencing financial crunches, and we're getting some notes here from Professor Irish, I'll check those in a second. If you need a short-term loan or a grant, again, you can also check with Prina. So she's really the faculty's money person, and the faculty does have resources to support. And given the uniqueness of this situation, I think we can be pretty confident that the faculty is going to be as supportive as it can be given its resources. And apparently Prina is available on the advising portal, I'm just told, so you can go there. All right, let's continue on. So we created an announcement, as it says, with respect to survey and interesting photos and such. So let's take a look. As of 1 o'clock, we had about 75 responses total, noting that 12 of those are incomplete. And we know that some of you have continued to fill out the survey. It should be pretty quick. I'm hearing students say that it's about 5 to 10 minutes. And some of the stuff that you've shared with us has already been fed back into the discussions with the associate chair, with Professor Cluett, and with the dean. So this is really, really important in the sense of the more you help us help you, the better. And we get that your situation is changing. Do your best to fill out the survey. But as I've said, it's already coming into play with respect to technology, with respect to how we're going to be looking at time zones and scheduling. So the more we know, the better. Please keep going to that survey and filling it out. We don't have many photos yet, but we do have some, which is kind of awesome. Also, feel free that is a transparent PNG of the NSI logo, so you can use that. So I thought some of your classmates have been having fun in sharing. So let's see what we got here. So we have a Rubik's Cube with some stickers on it. We have some paper, actually no stickers, just paper and some simple cellophane tape. I got a question, so I'll come back to the question in a second. Again, it's pretty simple. I don't necessarily know what its purpose is, but if it's helping, and it's with whatever you can scrounge around the house. I'm just going to go back in time for just a moment. If you did the survey as the test, please do. Please redo it. And the token for the survey is the standard UTOR ID plus last 6 of your library. One of the members of the teaching team will dig through the lectures from last term. I believe it was lecture 1 or in the first 2 or 3 when we showed you the algorithm that you can use to generate your token. But it's your UTOR ID concatenated with the last 6 digits of your library number. Not student number, library number. It's the one on top to the right of your barcode. So, all right, I'll do this, but don't anybody steal my token. So we're just going to hide a couple digits here. It's the number up here under my thumb, which I'm not sharing. All right, onwards. I have no idea what this is, but it's doing stuff. I got a cart. I think I see some foam core. Wait a minute. Wait a minute, I know this. This is Walmart. I've seen this at a Walmart. That's pretty cool. So two different types of prototype, differing degrees of fidelity, differing degrees of function. I do note, go back into my little pointy thing, use of monitor parts for stands, use of foam core, use of whatever else was lying around the house. So kind of awesome. One thing I do want to say, this is awesome. We are not expecting every team, every individual to be doing this kind of prototyping. You might not have access to physical prototyping materials. I think pretty soon Dollarama is going to be closed as being a non-essential store. It's totally okay that you don't have this kind of prototype. If you do, great. If not, we are just as happy if you do that kind of sketch and free body diagram and sieve solution. We're probably pretty happy if you just have a bunch of reference designs that you found online and you kind of talk us through it. All right, so we are super happy to see what you have, but there's lots of other ways, hand sketches, calculations, simulations that you can use to demonstrate to us what you're thinking and why your concept makes sense. But I got a pretty good, to be fair, I got a pretty good feel from that as to what the intent is with having sort of a hinged bottom. I'm going to assume that the key is that there's the hinge. It's different at the back there on the cart. All right. Another thing here, which I think is kind of cool. Certainly having a secondary display is awesome. I can't really survive without them. But just a couple points to raise here. We've got different, framing and scoping. So you can always tag things and create your own sort of subfolders. There's the structure that we've asked of you, but there's also the structures that you create for your own purposes. And I think as people are starting to do, and as was discussed during the check-ins with your teaching team, using a sort of a presentation to organize things, to talk about different aspects of process, to show us representations. I mean, what I'm seeing here in this photo is awesome in the sense that I can get a feel that the team has been capturing, the team has been moving forward, the team has been structuring their thinking, and then is turning it into something of a more structured and collected form. This is awesome. This is what we're looking for, which is great. So the more you can send PhotoWise to us, the better. But before I move on, we want to get some feedback. So as you know, we delayed beta for a week, and the teaching team feedback was that it was really good that we did because people have been moving around, but also the technology wasn't perfect, but it got there by the end. So I want everyone who's online, Mattermost-ish, please, Discord is okay, just to sort of reflect on the process of doing those check-ins, but also what value they did or did not have for you. So the meta question, how did check-in go from a technology point of view, from a community point of view, from a team point of view? I'm going to stop talking for a second and see if I can find something to soothe my throat, which is fine. It's just a little dry. Apparently, I'm the only one on Discord. That's awesome. So we're going to use Mattermost because Mattermost is cool. How did check-in go? Take 2 minutes. I will try to remember when 2 minutes is up. All right, so that was freakily quiet as people keep coming in. One of the goals I think that we have for those check-ins is that they kind of continue to create a sense of, for lack of a better term, normalcy. Um, you've been checking in every week. It's something that you've done in the past. It's something that we'd like to continue. It keeps the dynamics of the course and of your teaching team and your studio folks together. Um, so we're really hoping that um, much less than 2 minutes. That was less than 2 minutes. Okay, that was freaky. Um, all right. All right, I do want to move on, I think. I'm just looking at what's going on. Um, let's move forward. But what we're gonna, so what's happening right now is Professor Sheridan and other members of the teaching team are watching on Mattermost. Um, and they're gonna collate what you said. We're gonna respond to it as we go. Gonna move on. Apparently some of you have been having fun working on things. And let's see. So apparently, Foster's favorite method of generating new ideas. I'm going to riff a little bit off of someone say Picasso, some would say Steve Jobs because it's an Apple Day. And the sort of tagline is good artists borrow, great artists steal. Now, granted, in an academic realm, you can't do that. So I'm just going to pop this in with appropriate attribution. Pretty important. So I don't actually know what beep boop is. I find that eternal internal screaming eventually drowns out a lot of the world that's distracting. So there's a place for it, but we'll see. Da 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 da. But let's talk about this one because it's a passive aggressive tells feedback. One that kind of doesn't follow the PIAA model and the other models that were there. But let's actually talk about teamwork right now for just a moment. I'm going to be dealing with, or not dealing with, I'm going to be taking a little bit of the stuff that Professor Sheridan and I talked about. We're still working on multi-person here, which is one of our goals. All right, first things first. Incredibly challenging times. I don't think anyone can really deny that. I think it's something that we're all going to have to be working through. And there's constantly it's challenging in part because new information is coming out all the time. So that's one big thing. It's going to probably be more difficult to work together as a team. The Praxis teaching team, similarly, is trying to learn how to work together remotely. The cognitive load, the visual load, the challenges in coordinating. So there's a lot more challenge when you're working together as a team remotely, which many of you are. So first things first, we get this. We're trying to do what we always do, which is to accommodate and be flexible. It's why that survey is so important. It's why we want very much to understand your situation because that allows us to plan accommodations and be flexible. But that said, there are some expectations on all of us, teaching team, students, the works. Act professionally towards your teammates. Now, for some of you, and sometimes even within the teaching realm, what does professional mean? Some of the things that I think would be included under professional might be actually sharing what's happening with folks, actually acknowledging that their situations matter to them as much as your situations matter to you, actually wearing appropriate, basically, is a bathrobe really the right thing to have on when you're doing a teaching team meeting? These are interesting questions that can be negotiated amongst your team members. So act professionally towards teammates. And if you're ever wondering what professional looks like, Professor Sheridan, myself, others. Number two, Keep your teammates in the loop. Keep us in the loop. Your situation is evolving, and we want to be able to accommodate and adapt as that situation evolves. We are totally okay if you can't make it to the online beta, then if your teammates know, and we say, hey, where's so and so, and their internet's out, they texted us beforehand, or they have to go in and take care of a family member, or there's something happening. If everyone's in the loop, we're okay with that, subject to the last point. Work with the teaching team early, right? If you're doing more or less than you think is fair. The goal is not for Praxis to take over anyone's academic career. We want you to work on it because you're passionate about it. We want to make sure that, sorry, it's really tricky. I'm still struggling to have too many things. We want people to work on the course, but for it not to distract from the rest of their situation. If working on Praxis is really enjoyable to you, that's good. But if it ends up that you are carrying your team even more so now than you might have before, that's not good. So keep us in the loop, work with us early if you're doing more or less than is fair. And especially given the changes in overall assessment policies, CR, NCR and such, we want to make sure that everyone is able to succeed at a level that is fair and appropriate for them. Professor Sheridan has made one quick point. Professionally, when you're doing remote work, might include everybody turns off their videos because that'll drop bandwidth requirements. So if you have members of your team whose internet connectivity is lower, then a means of being professional and fair is to drop down the requirements by getting rid of video. And as always, Professor Sheridan is available through a number of media. She's on Mattermost sometimes. She's available via email. If you're having challenges with teamwork, please come to us early so that Professor Sheridan can be part of this. All right, a couple other new points because we're going to have to get to some content soon. We're looking for alternatives to YouTube. The library has some. We've posted our last 2 lectures there. We don't know whether it will work behind firewalls. We're exploring this. Your help in exploring things, super valuable. So we're going to keep searching for alternatives that are international friendly. We, of course, are not currently there, so we're not entirely sure what's available. We've heard about Bilibili. So we'll see if that's a possibility for getting things up. We know that other profs are also using YouTube, which is not available internationally. So the more you can help us figure out where and which services to use, the better. But we're going to keep looking. Remote access. A number of you have talked about it. If you go and follow the path, here's what it's going to look like. You're going to come to this site that'll allow you to set up your remote desktop. It'll look something like this if you're on a Mac, and I assume that Windows is similar. Not easy to see. This is what's important. Set up the proper host name. It'll complain about your certificate when you connect. That's fine. It's just because of the way they're doing mass certificates. Second point, fit session to window, I think works really, really well. It means you're basically guaranteed to see everything you want to see. I'm using the university right now, so I'm high quality optimized. I'm going to suggest that you actually switch to low quality otherwise. One quick point that I should have circled and didn't. Update the session resolution on resize is really nice. It means that no matter what you do, things match how you've resized for yourself. And last but not least, it's really convenient to share something local. So I use my downloads as sort of a commonplace, and then you can use it on your PC. It's not the fastest, it'll do in the pinch. Those of you who are on tablet, we know some of you are, there is an iOS client. It's not the best experience, but it can actually work. And here's what it looks like if you're running on a Mac. It's basically ECF, and you can see that I'm doing that little thing where I've shared downloads on my iMac Pro so I can copy files in and out. You get access to Adobe Acrobat Pro, so you can actually edit PDFs and do cool things. You can also get access to SolidWorks. So all of the ECF tools are available to you. We're not advocating SolidWorks, but if you happen to want to use a legal version of it, totally go okay and do that. So ECF remote, not bad, little pokey, gets the job done. It also, and here's where MSE160 comes in, you get access to CES EduPack. And if you dip into there and you're saying, one of the claims you want to make during beta or later on in the term is that we should totally make our thing out of polyvinyl chloride, you can go into CES, get information on PVC, and more importantly, not just get this kind of general information, although it's good to know Young's modulus and tensile strength. You can get a lot more properties and you can start to compare. Cool thing about this is that you have a resource you can draw upon to learn how to use this tool, and that's Prof. Ramsey. So he knows everything that you will need to know about CES and material selection, and you can always contact him directly if you so choose. So you've got a lot of options that are still available to you from the point of view of what tools to use. There's also using VNC. I'll try to screencast more details this weekend. It's a little more challenging. Still more tools. Sorry to do this, but we think it's pretty important. And this is UTOR VPN. We have verified that, so it's still a bit of a question as to how versatile it's going to be. We've verified that it seems to work in China through the firewall. So you're going to be able to basically access online resources. So things like TechStreet, all the stuff through the library, all of that is available if you UTOR VPN. So we are now potentially, given the survey results, able to say, well, did you consult the standards because you have access to TechStreet? A super, super, super important point. It is UTOR. I strongly urge you to stop torrenting before you connect to the university's network. They respond surprisingly quickly when they see stuff from, say, the Motion Picture Association of America flying through their servers. So turn off all the stuff you don't want U of T to know about before you use the VPN. Getting connected is pretty straightforward, although some of the clients are being a bit of a pain. If you're on Mac OS or Linux, you can always use OpenConnect, and it works just fine. I don't trust commercial software. I have significant issues with respect to installing software that seems to want to take over my computer, so you can also do this. But however you do it, you can connect, you go to general.vpn, and you authenticate with your UTOR ID. Tells you how to check whether it's working, just like any other VPN, but assume that the university knows that it was you and it was your IP address that was in play. So just be careful. All right, TRIZ reference designs, generic Altschuler, some TRIZ tables, and hopefully parametric solutions. So let's move forward. We've got about 17 minutes. So Professor Sheridan showed you a little bit about this, TRIZ and the notion of the contradiction table. I don't think you heard about the history of TRIZ. And it's really kind of interesting because it's fundamentally, I'll post all links on Quirkus in an announcer, the teaching team will after the lecture. The way TRIZ started is purely based on reference designs, but a very particular kind of reference design. So they got a little bit of history. I'll just re-amplify because I want to tie this together. And if it's redundant, well, let me take a few minutes for redundancy. The key is the reference. Okay, so they've heard this. So you've already heard that you take a ton of reference designs in the form of patents, and then you abstract the daylights out of them looking for contradictions. You can kind of do the same thing. And that, going back to the Manola Blahnik, going back to the need to build a keyboard stand, you take a bunch of reference designs that have had to address the challenge of how do you put something in space without having kickstands and other such things. You find out who's done that in different realms, you abstract and go. So I'm not going to focus on that. Professor Sheridan also showed you this contradiction table. As it says, each cell is a contradiction. Let's actually dig into this a little bit, because there's that idea of contradiction, and that was a fast jump. I found this. I'll post the link to it. This is all of those principles, but with a little more example. So it says, what do you do? What's principle 01? So principle 01 is the notion of division. I kind of love the fact that there's a huge variety ranging from this idea of using bulkheads, removable replaceable bulkheads, through to breakable or brokeable chocolate. But this idea of, and then good old Lego blocks, interchangeable components, dividing things up into definable elements. It's simple and straightforward. Like, you look at this and you're like, well, yes, you divide things up into distinct elements and then put them together. Seems kind of obvious, but sometimes people want to keep it a little bit more together, and there you go. Again, excessive or partial action. Do more than you have to so that you can then extract out only the relevant bits. And this really comes up, I would say, in divergence. We really want you to be excessive in your divergence. Come up with tons and tons and tons and tons of ideas, spray excessively, so to speak, and then let your requirements sort of strip off the excess. Because the more you have, the more coverage you have. The more coverage you have, the more likely you are to have found something that's going to work out really well. All right, so we're going to try this. Convert harm into benefit, blessing in disguise. So I will ask, I'll try to time this better. You have 1 minute on whatever platform, ideally Mattermost where Professor Irish is, but wherever you are, 1 minute to tell me a super awesome thing you can do with explosives that makes the world a better and safer place. The answer is not blow up 401 Dixie Nissan. So you have explosives and you want to make the world a safer, better place. Go, 30 seconds. It is really weird to sit here doing nothing for 30 seconds. I don't like it. You really want to experience my singing voice? If I can practice my hand washing technique as I wait for 30 seconds. So I'm going to, as people finish off, I'm going to pick a few that I think are really, for me anyway, personally, given my interests, kind of neat. Reactive armor for tanks is pretty cool. You've got something trying to like blow you up, and so your armor blows up the other way. So your explosion pushes against the other explosion to keep you alive. There's the notion of you take the explosion that's causing damage and you put a really strong tube around it with an opening at one end, and now you can fly up into space, which is pretty cool. The notion of using it for mining, fair enough. Here's a neat one that I heard about when I was younger. You can, if you have an I-beam, a steel I-beam, and you want to cut it in a really fast way, you take some plastique, you wrap the plastique around it, you detonate it, and you'll get almost a perfectly smooth cut. Shaped charges, the math behind shaped charges is super, super cool. All of this is ways of taking stuff and using it this way. The one I kind of like, if you have a burning oil well, so this is the one up here in the corner, there are very, very, very few ways to put out a oil well other than detonation. You let the explosion blow all of the oxygen there, and boom. The other one, it's not explosions but fires, is the notion of a fire break. Right, so that's kind of fun. All right, Some of you might have heard about this one. This will be fast. Um, Periodic action or pulsed action. So instead of doing something continuously, you do it in a pulsed or periodic way. Really fast. Any quick thoughts? Either chat of to when is it really useful to do periodic or pulsed action that you've heard of at all? Speakers, hydraulics. Hydraulics gets really interesting because you end up with what's called a hydraulic ram, which can be really messy. Blending food. Okay. So CPR. Okay. Anything digital. Yeah, I think in a sense what you're saying is, the world is analog and there's digital and you got to convert between the two. All right. So the one that people tend to talk about in the context of NSI is what's called pulse width modulation, PWM. So if you can only turn something on and off, but you want to get 70% of it, for example, you simply have what's called the duty cycle. So it's still going to run at full speed every time, but in a given length of time, it's only active 70% of the time. So PWM is kind of a cool way of using periodic or pulsed action to give yourself fractional response when all you can do is on or off. So it's kind of neat. Amplifiers as well. So you'll almost certainly be using it in Praxis 3 because it's one of the very few ways that you can do Boolean, 0 or 12 volts and get like 2.5 volts. So some of you are there any good websites for this? Tris 40 is not bad. Oh, I'm going to go back one. I have a few minutes, I think. Got 8 minutes. Let's say here's the situation. I'm going to jump ahead and I want to sketch this because this is also a classic in the field. So we're going to jump to something I can draw on. No, come back. No, done. Okay, so here's your situation. You have a vat that you're trying to mix. So you have a big vat, you're trying to mix like huge. We're talking like big. So big mixing vat. And when you're mixing it, you want to get full coverage of the mix. So you can't kind of, the concern is why don't you just, you can put a lid on this because, and you can then run your stir stick through. Yeah, but you're missing, if you run your stir stick around, there's lots that isn't being covered. All right, so I got a big vat. I want to do really, really good mixing. So full set of mixing. But there's a problem. The problem is the stuff that you're trying to mix is super reactive to oxygen. Super reactive. Like when mixing, O2 very bad. Like we got some serious oxidizers here, like really bad. So here's the question. Here's the challenge. How do you cover the vat to ensure safe mixing? All right, take a minute, 1 minute. How do you cover a vat where if there's any kind of O2, your mix is going to blow up, but you actually need to get full coverage? 1 minute. You guys are way too good at this. Are you using Google? Be honest. Okay. I want props to Gary for doing Google. Google is a tool. I totally respect Google as a tool. All right. Uh, awesome stuff. The classic answer, and some of you already got the classic answer, is you put an inert gas on heavier than air inert gas. So it's got to be heavier than air plus inert. And nitrogen is in fact the one that's usually used. So, get the stuff in there, put the nitrogen on, boom and go. I love that some of the other ones that you did, you're like, let's get rid of all the oxygen. Okay, not a bad one. You're kind of expanding the range of your solution though, but this is awesome. But this is the idea is, you know, Triz would say, I need something that is permeable, but also airtight. So this is where Triz comes in. I need a permeable plus airtight. That's your contradiction. And then you go look it up and find out, okay, how do we make this happen? So that was fun. And some of your ideas were awesome. Nice to see divergent thinking. So let's get back into where we were because I had to duck out for a second. Okay. So here's an example, TRIZ 40. They show you, there's segmentation number one. The idea is that you set your contradiction. I want something to be, for example, durable, static, and easy to repair. And then it gives you what you should do, independent parts, easy disassembly, degree of segmentation. And then it gives you some examples such as modular furniture, quick disconnect joints, truck and trailer, powdered welding. So the idea is that none of these are going to work perfectly for you. They're really inspiration more than they are a direct application, but they're still there. And it then can go backwards and say, let's look at the following contradiction. So you can kind of go from contradiction to solution to contradiction and back. The rhetorical question, because it's going to change for all of you, and I don't think we have time to get there, is which contradiction is your opportunity trying to address? Now, again, you're going to have to abstract a little. You're going to have to look at it and go, well, are we really dealing with an issue of speed versus power or control? Are we dealing with durability versus modularity? There'll be some abstraction, but if you can do it, you can then immediately come into here for inspiration. So I'm going to leave you with one more little beat, and it is a question for you. So here you go. You're doing some work, you're solving some stuff, and you're given U unknowns. And you're given E equations, and what I forgot to put in because I was moving quickly because of the fire is the critical part, which no one's going to like. U is greater than E. You're asked to give a solution. So what do you do when you're asked to give a solution and U is greater than E? Take a minute, figure it out. I would like to thank the class for, in the first 5 seconds, allowing me to fish out exactly what I was looking for. There we go. So those of you who are online right now, you are on this, which is kind of awesome. And I think I'm down to my last minute. So yep, justified assumptions are perfectly reasonable when you're doing engineering solutions. You got to justify them, you got to claim them. But if you're like, well, you've only given me E, so I'm going to create at least
15 hours.
U minus E assumptions. The other, as you talked about, parameterized or free variables. So when you're in the early stages of a solution, you can parameterize and say, look, our concept here, we don't know, our stakeholder hasn't fully scoped this out for us perfectly. So our solution is parametric in the key questions we're going to ask our stakeholder. And then later on, you'll work it out. We just hit time. Thank you all for being here. Thank you all for your fast work on the chats. Good answers coming up. Hopefully that helped you understand TRIZ a little bit more. The teaching team is going to go through the chats and we're going to post. Otherwise, stay in touch. We'll talk to you on Monday. Enjoy the weekend as best you can. Get out in the sun. Go for a walk if you can. Take care. We'll see you soon.